So in this next section, we want to look at hypothesis testing and exactly how to perform one. But let's try to get a better understanding of exactly what a hypothesis test is. Let's start with this situation where I'm flipped a coin and I'm measuring the number of tails that I achieve, and the probability of success is 0.5. How many tails would I expect? Well, I would expect to be 1 tails, and I would also expect there to be 1 heads. Just because I don't get what I expect, it doesn't automatically mean that the coin is biased. What if I got 2 tails? Well, the probability of getting 2 tails is 0.25. This is quite a large probability. There's a chance that I could get 2 tails on a fair coin. So I couldn't use that outcome as evidence that the coin is potentially biased. 25% is a large percentage. What percent would I need for me to be suspicious that the coin is biased? The level of suspicion we usually set around 5%. This is specifically called the significance level of the hypothesis test. We're not going to be suspicious unless a probability falls below that significance level. So here, when I flip the coin 4 times, if I was to get 4 tails from 4 flips, the probability of that is lower than 10%. It's 0.625. Not quite enough to be suspicious. Let's move on to 5 flips of the coin. If I was to get 5 tails from 5 flips, well, that probability is less than 5%. That probability would have me suspicious as to whether or not the coin is actually fair. So our hypothesis tests are just going to be about how unlikely is this event to happen with a fair coin, which leads into how suspicious am I of whether or not this coin is fair. Let's have another look. This time the coin is flipped 8 times. I would expect there to be 4 tails, but how many tails could there be that would make me suspicious? If all 8 of them were tails, I would be suspicious. We can see from the graph that probability is very, very low. But are there any other outcomes, any other values that would also pique my suspicion? When we're checking how suspicious an outcome might be, we always take that outcome and anything more extreme than that outcome. By more extreme, I mean further away from the expectation. So if I wanted to check 7, I will check greater than or equal to 7, moving away from the expectation of 4. So I really want to make sure I get the tail. I want to get the top end of the distribution. Greater than or equal to 7 is still quite a small probability. It's 0.0352, which is 3.5%. That's still less than the significance level, the suspicion level of 5%. If we checked greater than or equal to 6, this once again has a large probability, 14.45%. 6 tails from 8 rolls wouldn't be enough for me to be suspicious whether this coin is fair or not. But 7 tails from 8 rolls, that would get me thinking. That would get me suspicious. How many tails would I need from 10 rolls for me to get suspicious that this coin is biased? Well, we're going to need to calculate some probabilities. Is it 6, 7, 8, 9, 10? We've learned how to calculate cumulative binomial probabilities on our calculators, but I'm going to use this table that I made as a quick reference guide. Would I be suspicious of 7 tails out of 10 attempts? Well, greater than or equal to 7 is 17.19%. That's still quite large. It wouldn't be enough for me to be suspicious. How about 8 tails from 10 attempts? Well, the probability of greater than or equal to 8 is 5.47%. So that's really close to the 5% that we typically set, but it's not less than that 5%. We usually and typically go for it being less than the significance level, less than the suspicion level that we set for ourselves. 9 tails out of 10 would make me suspicious, because greater than or equal to 9 only has a 1.07% chance of occurring with a truly fair coin. So there's just a couple of things I want to point out before we move on. Firstly, we don't always have to get the expected value for the coin to be fair. There is some variability, and there are other outcomes that you can achieve without necessarily thinking that your coin is unfair. Secondly, when we calculate probabilities, we never calculate just an individual probability. We find a range of values. We check a value and everything even more extreme than that value. Thirdly, sometimes if the sample size isn't large enough, there are no outcomes that will lead to us being suspicious of the coin in the first place. Flipping the coin twice or 3 times will not enough for us to become suspicious of the coin based on its outcomes.